Yeah, good day guys, and welcome to this video. And this video is we're gonna talk about the word trigonometry. But before going further, we need to consider what we mean by the word an equation. An equation is simply means where two terms are equal, like if we have x equals to 2. So, or we say x plus 2 equals to 0. Those are all equations where two terms are equal or when two or more expressions are equal. Is that what we refer to as an equation? But further that, we have four types of equations. We have the first one to be an equivalent equation. Let's just write them. The first one, we have equivalent equation and the second type we have identity equation. The third type we have conditional equation, and the last one we have inconsistent or something which is very contradictional or contradictional equations. So mainly for equation, these are the four types of equations, and we have to take note of that: equivalent equation, identity equation, conditional equation, inconsistent or contradictional equation. So further, what do we mean by equivalent equation? An equivalent equation, this is an equation wherein you have two or more equations that have the same solution. Example, if we have 3x plus 4 equals to 0, and we have 3x equals to minus 4, and we have x equals to minus 4 over 3. These equations are equivalent. If you consider this equation, when you solve it, you have a result. You consider this equation, you work it, you have a result. If you consider this equation, you work it, you have a result. So since all these equations, the result you are going to have is going to be the same, the value for x in every of these equations will give you the same. So such equations, we refer them to be equivalent equation. So an equivalent equation is what two or more equations that have the same solution. Now, that have the same real value of the variable. The second type, an identity equation. What do we mean by identity equation? Identity equation is an equation that satisfies every real value of the variable. That means any value you think of when substituted into that equation, you are going to have the same. The value for the left-hand side is going to be the same to that of the value on the right-hand side. So such equations, we refer them to be identity equations. So identity equation is any equation that can satisfy any real value of the variable. Such equation, let's say if we have x plus 1 equals to x plus 1, this is an identity equation. Any number you think of, it is of x, when slotted on the left, you slot the same number on the right, you find out that the result is going to be the same. You see, we can also have something like sine square x plus cos square x equals to 1. Any real value you think of for this variable, you substitute it here, you substitute this same value here, the result you are going to have is going to be 1. You think of x to be minus 2, x minus 2 here slotted, x here minus 2 slotted. The end of the when you have the two values, you are going to have 1. So such equations, we refer them to be identity equation. So you see, so we'll consider the next part. So identity equation is going to be our topic here, which is trigonometry. So that's going to be our first heading where we will consider the identity. We are going to derive all the identities under trigonometric ratio. So you have to know what we mean by identity equation before we start under trigonometric ratio. So the other type of equation we call conditional equation. A conditional equation, this is one of the equations widely used in high schools and in university, because most of the problems you solve, you might have the variable to be one unknown or two unknowns or three unknowns or four unknowns. So you see, so all of those fall under the category of conditional equation. From word conditional, these are equations which are conditioned, or these are equations that can only satisfy few of the values of the real to those functions of the variable of the domain. Right? What do we mean by an conditional equation? It simply means an equation that can satisfy few of the values of the variable of the domain. an example of conditional equation, we can have x plus 2 equals to 0. It is a conditional equation. The only value of x that will make this equation true is minus 2. There is no other value which you can substitute here that will make this equation becomes true, or that will make the statement becomes true. So the only value there is minus 2. You cannot say you put here 2 plus 2 will not give you 0. I cannot say it's plot here 3 plus 2 is 0, or minus 3 plus will not give you 0. So the only value which can make this statement true is minus 2. So such equations, we refer them to be conditional. We can as well have x squared minus 4 equals to 0. You see, so such equation, there are only few of the values of this x that you can set it, that can substitute here that will give us 0. There is not all values of x when substituted here that will give us 0. So only limited values of x that will be substituted to this equation that will give us 0. So such equations, we refer them to be conditional equation. The other part again, we consider the last type of equation which we call contradictional, or which you can refer to as inconsistent. So contradictional equations are equations that cannot satisfy any real value of the variable of the domain. That when you solve it, let's say you have x to the 4 or 5 or 6 or 7. So if you substitute that value you got into the equation, you find out that the statement will be untrue. The statement will not satisfy. So such equations, we refer them to be contradictional. An example of contradictional, you can have x plus 2 equals to x plus 1. This is contradictional. There is no number you can substitute here that will make the left to be equal to the right. So such equations, we refer them to be inconsistent or contradictional equations. So these are the main types of equations. We have equivalence equation, identity equation, conditional equation, inconsistent equation. These are the 4 types of equations. So our heading here is going to be an identity equation. So how can we play with identity equation? So if we consider identity equations, so our focus here is how we can have the identities under trigonometry. You see, so to have the identities under trigonometry, one of the ways we can derive them using a circle with axis. Let's say we consider a circle, so and we have the axis for both x and y. Let's say this is the y-axis, and we consider this to be the x-axis. So having these two axes, and the center of any circle, let's say here is 0. So further, let's say from this center of the circle to any part of the circumference, we refer it to be the radius. Since this radius and this horizontal line forms an angle, let's call that angle to be theta. You see, so if we continue, let's say we drop a perpendicular line from this point, coordinates, let's say we name this point x, y, and this point, this is the vertical, let's name it to be y, and this here, we name it to be x. So we have a basic diagram for this. Let's extract that diagram. If we extract that diagram, here is going to be theta, and here is this. You see, so if we have this value, here is theta, here is x, and here is y. So in this form, we can consider the acronym, let's say SOHCAHTOA. Let's consider this word, SOHCAHTOA. If we consider these words and how we can able to have the identities under this heading. So we have here the radius r, this is the x-axis, this is the y-axis plotted, this is the angle for the triangle. So in this case, how can we use the first one? Because this s is representing sine, this is cos, and this is tan. The o is simply the opposite, the a is the adjacent, and the h is simply the hypotenuse. But how can we identify them when the diagram is given? In simple form, always the side which faces the 90 degree, that side is the longest side, and the longest side is called the hypotenuse. In another way, the side which face the given angle, so that given angle is simply the opposite. And therefore, the remaining side is the adjacent. In a simple way, let's consider this diagram given. So let's say here is angle theta. Let's say this angle is given as 30 degrees. So how can we identify these three sides? In simple form, this is the 90 degree. The side it faces is definitely the hypotenuse, which is the longest side. This is the 30 degrees, so the side that faces the given angle is simply the opposite. And therefore, the remaining side is going to be the adjacent. This is the simplest way of identifying the sides of the right angle triangle when a given angle is provided. Short. So, having this, let's say we take the first one to derive these identities. Sine theta is simply O, which is the opposite all over H with the hypotenuse, and the opposite from this diagram is Y, and the hypotenuse from this diagram is R. So if we cross multiply, Y is going to be R times going to be R sine theta. Let's call this equation A. So we take again the second one, cos theta. Cos theta is adjacent, which is A, all over hypotenuse, which is H, and adjacent here is X, and hypotenuse is R. So cross multiply, X is going to be R cos theta. Let's call this equation B. So if we use the same way for tan, we say tan theta is opposite O divided by adjacent A. So the opposite is Y, and adjacent is X. So therefore, tan theta Y is this, which is R sine theta, and X is this, which is R cos theta. So you can see R cancel R, so we have sine theta all over cos theta. So this gives us the first identity. Okay. So the first identity is sine theta equals to sine theta all over cos theta. This is the first identity we carefully derive. So if we move to have another identity, let's say we square this term. If this angle is squared, if we square tan theta, we are going to have tan square theta. If we square again the left hand side, we square sine square theta, and we square again the denominator, cos square theta. So this gives us the second identity. So the second identity simply be tan square theta is going to be sine square theta all over cos square theta. Yeah. So we have this. So if we move again, we also have, because like cot and tan, they are related, you see, and the relationship between cot and tan, they are inversely proportional, which means cot theta is inversely proportional to tan theta. So this also gives us another identity, which you can call as a third identity. So if we also move forward, we consider, since we have cot theta, we can also square this. If we square cot, it's going to be cot square theta. If we square 1 is 1. If we square this, it's going to be tan square theta. So this gives us equation 4, or identity 4. So we have this. So the other point, we can as well consider sec theta. Sec theta is inversely proportional to cosine. So we have cos theta. This gives us equation 5. So sec theta is 1 upon cos theta. So if we square both left and right, so we square this sec square theta, we square 1, we square is going to be cos square theta. This gives us identity 6. Yeah, this is how we have them. So if we move again, we take again cosec theta is inversely proportional to sine theta. This gives us identity 7. And if we square both left and right, so we have cosec square theta is going to be 1 upon sine square theta. This gives us identity 8. So this is how we have this value. But with respect to the diagram, if you consider this diagram, we have here R, X, and Y. So we need to find the value of R with respect to the triangle. So one of the laws we think we can use here, we can use Pythagoras theorem, which states that the side of the longest, the square of the longest side must be equal to the sum of the squares of the remaining two sides, which implies longest side is R square equals to the other remaining two sides will be X and Y. So the sum of the squares of these two sides must give us R square. So if we implement that, this is going to be X square plus Y square is going to be r squared, you see. But what is x? X is this, which you can say r cos theta, plus what is y? Y is r sin theta, all square equal to r square. So if we expand, it's going to be r square cos square theta plus r square sin square theta equals to r square. So if we simplify this, r square is common, we factor r square, it's going to be cos square theta plus sin square theta equals to r square. So r square cancel r square. So this remains cos square theta plus sin square theta. This gives us 1. This gives us identity 9. This is how we have this identity. So having these identities, so the next point we can further have similar identities. We can think of saying, let's say we divide both sides by cos square theta, or we say divide both sides by sin square theta, to see what else we are going to have. You see. So if we divide both sides by cos square theta, let's rewrite it, plus sin square theta equals to 1. If we divide both sides by cos square theta by cos square theta by cos square theta, cos square theta divided by cos square theta is 1. Sin all over cos is tan square theta. 1 over cos square theta, 1 over cos square theta is 1 over cos is sec square theta. Where is it? 1 upon cos square theta. 1 upon cos square theta is sec square theta, so this gives us sec square theta. This gives us identity 10. You see? So we can do the same way. Since we divide here by cos square, we can also divide by sin square. So sin square equals to 1. We divide both sides by sin square theta by sin square theta by sin square theta. Cos and sin, cos square theta divided by sin square theta is cot. You see, is cot square theta. So we have it will be cot square theta plus sin divided by sin is 1. 1 over sin square theta. This is going to give us cosec square theta. This gives us identity 11. This is how we have this. You see. But in another form, for this cot, we can also have another identity. Cot square theta, since we have it to be 1 over tan square theta, we can as well simplify it. We say 1 divided by tan square theta. Tan square theta is going to be sin square theta all over cos square theta. This is going to be cot square theta will be 1 times cos move up. We're going to be cos up divided by sin down. So cot square theta we're going to be cos square theta divided by sin square theta. This will give us identity 12. This will give us identity 12. We can also have another similar identity. So since cot theta can as well be cos theta all over sin theta, this will give us identity 13. So this is how we carefully derive these values, these identities. So take our time. So after having these values, we can also think of complementary angles. And see, if we think of complementary angles, complementary angles is also another way of having identities which can help us to find the identity of double angles, half angles, and other related. So in this case, how can we find the identity of A plus B if we have this value? So if you have this value in simple form, it's going to be sine of this first, and cos will take the second letter. After that, cos will start the first letter, and sine will have the second letter. In simple form, this is going to be sine A cos B plus cos A sine B. That's going to be sine A cos B plus cos A sine B. So if the sine is plus, it's going to be plus. So the same maintains. If the sign is negative, nothing changes, only the sign. So say sine A cos B minus cos A sine B. This is how we have it. This is also another identity, identity 12. We can say this is 13. We can say this is identity 14. So if we move to cos again, we say cos into A plus B Cos is biased. Cos is not like sine. We are in mix them sine cos. Cos is biased. Cos will be one side, and sine as well will be on the other side. So we have going to be cos A, cos B. You see, instead of cos A sine B, going to be cos A cos B. If the sign is plus, it changes to minus, which is sine A sine B. This is the identity. So this gives us identity 15. If we take for the negative sign, cos into A minus B, this is going to be cos A cos B. The same thing, the sign will change. Since here is minus, it's going to be plus sine A sine B. This is identity 16. This is how we have this identity. So further, we can as well consider tan, because since we consider sine cos, we can as well consider tan. Tan again is also the same, tan into A plus B. But you know, tan is sine all over cos, right? Since we have A plus B, so definitely it's going to be A plus B divided by A plus B. So this is how we have the tan of these values. But in simplified form, which we are going to derive, A plus B can be written in the short form as tan A plus tan B divided by 1. Since here is plus, going to be minus tan A and tan B. This is identity 17, which you have to know. But we are going to derive this just after this. So we take the negative sign, it's going to be the same. It's only the sign that will change. So this will be tan A minus tan B. Down, the sign maintains. This here is minus, here is going to be plus, which is tan A, tan B. This gives us identity 18. So these are the identities we have to take note of. So having these identities, like I think this is the end for these basic identities. The other identities we are going to consider is double angles. So before we go to double angles, let's consider these two identities, this derivation. Let's derive these two. We can only derive one, but the format we are going to use to derive this is the same format you use to derive it. So we'll derive this first one, so you can take it as an exercise to derive this to have the same result. So the steps are going to be the same, nothing will change. So if we consider, you see, so say consider this identity, which is tan into A plus B equals to tan A plus tan B minus 1 minus tan A tan B. Why? So this is question mark. How we have that? You see, how we have that result. So in this case, we'll consider this value, tan into A plus B. So if we consider tan into A plus B, as we have given, you know, tan is the expression of sine all over cos. You see, so if you have tan into A plus B, so the expression of that is going to be sine into A plus B divided by cos into A plus B. So there we simplified, we'll find the identities for both the numerator and the denominator. If we simplify, definitely we're gonna have this value. So let's see what we are going to have. So tan, we know it to be sine all over cos. So since the angle given is A plus B, we can also write it A plus B, and down again is also A plus B. Simple and straightforward. So let's continue. If we expand this is going to be sine A cos B, and we take the plus sign, we take cos A sine B divided by cos again, the same thing, you know, cos is biased, cos A cos B, since it's plus minus sine A and that of sine B. There is it. But if you look at this expression and you compare what we are going to have, here is 1. There is no 1 here. There is minus. We are fortunate we have minus. This is quietly different to this. So the easiest way to arrive to this, make this value become 1. So make this value to become 1. So if you have 2, if you have to make 2 to become 1, you divide by 2, which will give you 1. So divide both sides by this same number in all of the terms given. I think that will help solve our problem. Let's see how best. So we say sine A cos B divided by cos A, cos B. For this one, we take the plus. We consider this again, cos A sin B divided by, we take this denominator the same, cos A, cos B, divided by, we take this again, cos A, cos B, divided by cos A, cos B, minus, we take this again, sin A, sin B, divided by cos A, cos B. This is it. So the expression for term into A plus B will look like, cos B cancelled, sin A divided by cos A is tan A, plus cos A cancelled, sin B divided by sin B is tan B, divided by, we'll come to this, cos A cancelled, cos B cancelled, so it's 1. Sin A all over cos A is tan A, and sin B all over cos B is tan B. You see, this is how we have it. So this gives us the identity we have here at 17. So you can use the same concept to derive this. The only thing that will change is the sign, but all the steps will be the same. So this is how we have the complementary angles. So having these complementary angles to be identity 17, 18, which is the last one, we can move to double angles and see what we are going to have. So if we consider double angles, let's write it boldly. Double angles. So double angles, we use the same identities. So if we are in the two angles given, the two different angles given, we make them to be the same. So if let's take for the first one, sine into A plus B, will give us sine A cos B plus cos A and sine B. So for double angles, we assume the two angles to be the same, the two different angles that A and B to be A equals to B. If A equals to B, it means where we see A or where we see B, we slot A. So if B is slotted as A in all the cases, so we have sin A cos A plus cos A sin A. So A plus A will give us sin 2A, and sin A cos A sin A, they are the same. So add this plus this, going to give us 2 sin A cos A. This gives us identity 19. So identity 19, yeah. So we have that. So the next point, we can, for double angles, we cannot consider the negative because we say A minus A is 0, so we don't have any something meaningful here. We just have 0 equals to 0. So we leave the negative sign, we move to the cos. So we move to cos again, which is cos into A plus B, which has an identity of cos A cos B minus sin A sin B. So this is it. So this again will look like if A equals to B, this will be cos into A plus A, and this will be cos A cos B minus sin A sin B. So A plus A will give us 2A, so cos 2A is going to be cos A cos A will going to give us cos square A. Sin A side is going to give us sin square A. So this gives us identity 20. Yeah. So having this identity 20, we can, but this cos 2A, we have a lot of ways to further simplify that. Let's say, but we all know that cos square A plus sin square A will give us 1. We should not forget this guy. This guy is very, very important in short cases. So cos square A plus sin square A equals to 1 is an identity. You can either make cos square A the subject, which implies you have 1 minus sin square A, or you make sin square A the subject, which will be 1 minus cos square A. So you can either make either of these for us to have another 2 identities for cos 2A. Having known this, let's take cos 2A. Cos 2A is going to be cos square A minus, let's substitute for sin square A. Sin square A is this, which is 1 minus cos square A, and this is going to be cos square A minus 1 minus plus cos square A. So add cos square A plus cos square A. This is going to give us 2 cos square A minus 1. This gives us identity 21. You see. Or in another form, we can as well, instead of substitute 1 minus cos, we are going to substitute 1 minus sine. So the same identity will look like cos square A, we have to be 1 minus sine square A, and we have our minus sine square A. So this will be expressed as 1 minus sine square A minus sine square will give you minus 2 sine square A. This gives us identity 22. You see. So this is how we take our time to derive these identities. So having this, we can also consider tan. Since we have cos, sine, let's take our time and have the other identities for the remaining. We can take tan into A plus B. We know it to be tan A plus tan B divided by 1 minus tan A tan B. So this can be simplified as if A equals to B, so tan, this is going to be A plus A, and this will be tan A. This again will be tan A divided by 1 minus tan A tan A. So A plus is going to give us 2A, so tan 2A equals to tan A plus tan A is going to give us 2 tan A divided by 1 minus tan A times tan A is going to be tan square A. So this will give us identity 23. You see, so this, I think these are the basic identities we need. So this is the first part, deriving, how we can derive the identities. So having these identities, which is a key point in trigonometry, because if you cannot derive these identities, you will find it very difficult to be able to work problems leading to trigonometry. So the other subtopic we are going to consider before we take some 2 or 3 examples, we consider circular measure. Circular measure. This again, another basic point we need to consider. So if we consider circular measure, is just a basic point of converting radians to degree, or we convert degrees to radians. How can we convert radians to degrees or convert degrees to radians? Those are some of the few points we just need to consider. So if we consider circular measure, let's use this side. Let's carefully use this side. If we use this side, circular measure. So if we use circular measure in this point, what we have to take note of, the radian for this value will give us 180 degrees. So this radian, which is pi radian, must give us 180 degrees. You see, so how can we convert from radians to degrees and as well as from degrees to radians? So converting from radians to degree, let's say from radians to degrees. So convert radians to degrees. Let's say radians to degree, x degree is going to be, because we are finding degree, so it's going to be 180 degree divided by pi times we multiply it by the circular value. You see, so it's going to be let's say we are looking for x, so x is going to be the radian. So if we are converting from radians to degree, so it's going to be 180 degree divided by pi multiplied by the radian value given. So if we are converting from degrees to radians, the same thing, just make x a subject. So radians is going to be pi divided by 180 times degree. You see, the format is, this is the format, x degree, x radian, we're going to give us 180 degree. let's say we are looking for x radian. So it's going to be, let's say the 90, the angle given is 90. So multiply this time this and this time this. So it's going to be 180 degree x radian is going to be 90 pi e radian. We divide both sides by 180, both sides by 180. This will cancel. So therefore, x degree is going to be 90 times pi radian all over 180. So in degree, it's going to be pi radian over 180 times this. So you see, so this is how we have this value. This is how we have this value. So if we convert this value, pi degree, 180 degree, x degree equal to 90. So in this case, degrees now to radians, degrees, if we convert from degrees to radians, is going to be 180 degree divided by pi times, let's see, if this radian is given as 3 pi all over 2, we're going to find out. So these are some of the points you need to consider. So let's say we take examples. Let's say one, convert the angles to radians. Let's say the first angle is 135 degrees. The second angle, let's say it is given as negative, let's say 40 degrees. And the third angle is given as 270 degrees. So how can we convert these values to radians? We are given this degree to radians, this degree to radians, these other degrees to radians. So degrees to radians, if we convert from degrees to radians, this is degrees to radians, we say xc is going to be pi all over 180 times, what's the degree given, which is x, we have it to be 135. So this is going to be, so divide 135 divided by 180, let's say 135 divided by 180. This is going to be 3 upon 4. So 3 upon 4 times is going to be 3 pi all over 4. So this is in radians. So the same thing, we want to convert this 140. This radians is going to be pi all over 180 times negative 40. So the same thing, 40 divided by 180 is 2 upon 9. So we're going to give us negative 2 pi all over 9. So this is how we convert. So you can still do the same thing to solve for the remaining one, the 270. So this is how we convert from degrees to radian. Now, if we are converting this again to degree, it's the same thing. So if we convert from radians now to degree, the radian given, you multiply by this, that will give you the degree. Let's see how best we are going to have shared. So in this form, we say the B part converts the radians to degrees. Let's say the first one we have pi all over 2, and the second one we have 4 pi all over 5. Let's say, and the third one we have 3 pi all over 7. We have this. So if we take these three values given, the radians, the first radian is this, the second radian is this, the third radian is this. So how can we simply convert these radians into degrees? So the format is x degree we're looking for. Look at it, it's going to be 180 degrees divided by pi times the given radian. But the given radian here is pi over 2. You can see pi will cancel pi. 2 into 180 is 90. So therefore 90 degrees is equivalent to pi all over 2. So the same way for the two parts, 4 pi, so x degree is going to be the same formula, 180 all over pi times the radian given. The radian is 4 pi all over 5. Pi cancel pi, so therefore 180 by 4 You see 180 by 4 divided by 5. This will give us 144. So it's going to be 144 degrees. So this is basically how we can convert radians to degrees and as well as degrees to radians. You see, this is the basic point. So after knowing that, we can also take examples on solve examples including the identities. Let's take other example. Instead of circular measure, let's take another example. So I have two problems here. Let's say worked examples. I can write them here, worked examples. Worked examples. So the first worked example says, example 2, because circular measure is that, prove that we have sine 3 theta divided by 1 plus 2 cos 2 theta should give us sine theta, and the second one sine into a minus b all over cos a cos b plus sine into b minus c all over cos b cos c plus sine into c minus a all over cos c cos a, all give us 0. And the last example would be okay, let me just write them here. I think here will be the best. So what example 2, let's say prove that this will be the best. Let's say sine 3 theta all over 1 plus 2 cos 2 theta must give us sine theta for the first part. And the second part says sine into a minus b all over cos a cos b plus sine into b minus c will look like cos b cos c plus sine into c minus a will look like cos c cos a equals to 0. So the last part will be like tan 3 theta is going to be 3 tan theta minus tan cube theta divided by 1 minus 2 tan square theta. So I think let's try these 3 problems. But the time is almost okay. We can see how best we can able to complete it. So we have these examples to solve using both the complementary angles and as well as the double angles. So the first derivation, sine 3 theta divided by 1 plus 2 cos 2 theta equal must give us sine theta. And the other one, sine to a minus b divided by cos a cos b plus sine to b minus c divided by cos b cos c plus this must give us 0. So the last one, tan 3 theta must give us 3 tan theta minus tan cube theta divided by 1 minus 2 tan square theta. So deriving require to prove that the left-hand side result must be equal to right-hand side result. So yeah, we can think of any value so this is done. So if we prove that, we take the first one to say consider given sine 3 theta divided by 1 plus 2 cos 2 theta to give us equals to sine theta. So we are required to prove that that value equals to this. So you can either choose the left-hand side or you choose the right-hand side. So here, in an easy way, let's consider the left-hand side. Sine 3 theta equals to 1 plus 2 cos 2 theta to give us this left-hand side value. So if we have that, but we need to find identity for sine 3 theta. This identity, sine can be expressed, 3 theta, we can make it as 2 theta plus theta, right? So this 3 theta is going to be 2 theta plus theta divided by 1 plus 2. This cos again, this cos 2 theta, we can do it again, cos into theta plus theta. I think this can be an easy way. So if we move forward, sine, this now is going to be sine 2 theta cos theta, which is sine 2 theta cos theta plus, and sine, since we start with sine, now we start with cos 2 theta sine theta, divided by, we consider also the denominator, which is 1 plus 2. This again, if we try to expand or find the identity for cos into cos theta, as we have been doing, it's going to be cos theta cos theta. Since the sign is plus, it's going to be minus sine theta sine theta. We put them in brackets because this 2 is affecting this value. So yeah, we further simplified. Sine 2 theta, we know it to be 2 sine theta cos theta from one of the identities. So this sine 2 theta is this, and we write our cos theta plus cos 2 theta again. You know, cos 2 theta is going to be cos square theta minus sine square theta from the identities, and we write our sine theta divided by, you see, this one again, this one, don't forget, you know, cos square theta plus sine square theta equals to 1. So we have C1, you can slot this. So this one will look like cos square theta plus sine square theta plus, we expand this 2 times, but cos is cos square, it's going to be 2 cos square theta minus sine is sine square, 2 times is going to be 2 sine square theta. So this is it. So we have this. We expand the bracket again. So we have 2 sine theta, cos theta times cos theta is going to be cos square theta plus sine theta times is going to be sine theta cos square theta minus sine cube theta divided by. Here we can have cos square theta plus 2 cos square theta going to give us 3 cos square theta. Sine square theta minus this is going to give us minus sine square theta. This is how we have this value. Yeah. So if we further simplified, we can see this sine theta cos square theta. Sine theta cos square theta are the same. We'll add them. The coefficient here is 2. The coefficient here is 1. So 1 plus 2 is 3. This gives us 3 sine theta cos square theta minus sine cube theta divided by 3 cos square theta minus sine square theta. You see? So how can we have this to be equal to this? If we look at them, here cos square theta, I think sine is common. We can factorize sine. So if we factorize sine, this expression, which is sine 3 theta divided by 1 plus 2 cos 2 theta, will be, if we factorize sine, which is sine theta, into, if sine is removed, going to remain 3 cos square theta, which is 3 cos square theta minus, we have 3 sine theta here, sine theta, sine theta, sine theta. Well, so when 1 is removed, it's going to remain 2, which is sine square theta divided by, and we rewrite the denominator, which is 3 cos square theta minus sine square theta. So therefore, these two will cancel. So the expression for sine 3 theta divided by 1 plus 2 cos 2 theta is going to be sine theta. So this is what we have. You see? So that's the identity. So we have that. You see? Yeah. So having this, we have the first one. We can as well consider the second one. If we consider the B part, so if the B part is considered, let's use this. B part, we have it to be sine into A minus B divided by cos A cos B plus sine into B minus C divided by cos B cos C plus sine into C minus A divided by cos C cos A equals to 0. So to prove that the left-hand side equals to the right-hand side, we can consider the left-hand side and we play with it to see that the result we are going to have is going to be 0. So if we continue one of the ways we find the identities for these top values. So the identity for this is going to be sine A cos B. Since here is minus, it's going to be minus cos A sine B divided by the what is given cos A cos B plus we come again to the second one, the same thing, we expand this sine B cos C minus cos C sine B divided by the bottom cos B cos C plus we take again this other expression which is sine C cos A minus cos C sine A divided by cos C cos A. This is it. I think this is what we have. So to further simplify it, we can think of ways that will be easier to see. So one of the ways, if I look at them, one of the ways I will divide this denominator by both of the two terms, this denominator by both of these two terms, this denominator by both of these two terms. I think that will solve our problem. So if we do that, we take this top, we say sine A cos B divided by the denominator, which is cos A cos B. We have a minus sign here, we write it. We also have cos A sin B, cos A sin B divided by the denominator, which is cos A cos B. We come to this plus sign, plus. We also consider this other bracket, which is sin B cos C, sin B cos C divided by this denominator, which is cos B cos C. And we have this minus sign, minus. I think this will extend to the other side, to the other side, to the other side. So minus, we done this we take cos C sin B, cos C sin B divided by cos B cos C, cos B cos C. Plus, we take the last one now. The last one again is also given sin C cos A, sin C cos A divided by the denominator cos C cos A, cos C cos A minus, because this minus sign will take cos C sin A, cos C sin A divided by cos C cos A, cos C cos C cos C cos A. Cos A, yeah. So if we look at them, let's see where ways is faced. There is a simple way. We can see that cos B cancel, and this will remain as sin A all over cos A minus here cos A cancel. This will remain sin B all over cos B plus here cos C cancel. This will remain sin B all over cos B minus here, want to cancel cos C cancel, this will remain as sin B all over cos B plus here, want to cancel cos A cancel, we have sin C all over cos C minus here cos A, cos C cancel, it remains sin A all over cos A. So this is what we have. So in simple form, sin A all over cos A is tan A minus sin B all over cos B is tan B plus sin B all over cos B is tan B minus sin B all over cos B is tan B plus sin C all over cos C is tan C, sin A all over cos C is tan A. This is it. Yeah. Though this, let's check the C parts, this middle one, sin B cos C divided by cos B cos C, and cos C sin B divided by cos B cos C. So in this case, we need to, and the last one, this, This should be cos C, sorry, this should be cos B and cos C. Cos B, this should be cos C, this should be cos this point, this should be cos B sin B, sin B, sin B over this is sin B over cos B is tan B. Let's check. There is something. So I think here we made slight mistake here. This expansion, this should be sin B cos C, and this should be cos B sin C. This should be cos B and sin C. Let me just clear this. This should be cos B and sin C. Because if you expect going to be sin B, cos take the second letter. Now the next one, cos will take the first letter, cos B, and sin take the second letter. Yeah, I think this is so going to be sin B cos C. Where is it? The second one, sin B cos C, and cos B. This will be cos B and sin C. Yeah. So you see, so down will be cos B and cos C. This is it. So you find out that cos B will cancel. So you're going to be sin C all over sin C. So you're going to be sin C all over cos C. So tan A, tan B, tan B. This will be tan C, tan C. So you find out that, so therefore the left hand side is this. It must give us 0. So you find out that tan A will cancel tan A, and tan B will cancel tan B, tan C will cancel tan B. So therefore 0 equals to 0. So this is how we have this problem. You see? So this is simple and straightforward. So we take the last part, C, the last part of the problem given, C. And see, we are given tan 3 theta is going to be 3 tan theta minus tan cube theta divided by 1 minus 2 tan square theta. We are also required to solve this. Okay, time is almost. So if we simplify this tan 3 theta, we can take this left hand side, tan 3 theta is the same as tan as the previous. This will be 2 theta plus theta. You see, we can express it this way. So we express it that way. We can just say, since tan is sine all over cos, so this is going to be 2 theta plus theta, and here it is going to be 2 theta plus theta. This is what we have. So if we continue, tan 3 theta, if we expand, this is going to be sine 2 theta cos theta plus cos 2 theta sin theta, as we have divided by cos 2 theta cos, because cos is biased, going to be cos theta plus, since here is minus, here is plus, it's going to be minus sin 2 theta cos theta. This is what we have for this point. So if we continue, we have tan 3 theta. This we can as well further simplify it. So tan 3 theta, its equivalent is going to be, we can as well simplify sin 2 theta, because at the end of the day, we need to have something like this. But sin 2 theta is going to be 2 sin theta cos theta, and we have our cos theta here, plus cos 2 theta, its expression is going to be cos square theta minus sin square theta. We have this, and we have our sin theta divided by, we take our denominator is going to be cos 2 theta. Cos 2 theta is same as cos square theta. I think This is the way. This is the way. This is the way. Yeah. Or let's use another simple way. Let's use another simple way of simplifying that. Okay, let's continue with this method. So we have this, so the end of the day we are going to have that value. Yeah, but let's just use another simple way of arriving that. This might take our time. Yeah, tan 3 theta is going to be, we should have something like 3 tan theta minus tan cube theta all over 1 minus 2 tan square theta. We can say this tan 3 theta, we can say tan 2 theta plus tan theta divided by 1 minus going to be tan 2 theta tan theta. I think this one makes sense. Let's see. So if we simplify now, this is going to be tan 3 theta. Tan 2 theta is going to be tan theta plus tan theta divided by 1 minus tan theta plus, we write this, tan theta divided by, we'll take the denominator 1 minus, I think, would that be? Yeah. So we'll take this 1 minus tan 2 theta is going to be tan theta plus tan theta divided by 1 minus tan theta all multiplied by tan theta. I think this step might help, might be easier than the one I wanted to use. So we say tan 3 theta equals to, if we add tan theta plus tan theta, this will give us 2 tan theta divided by 1. If we multiply tan theta, we're going to give us tan square theta plus tan theta. You see, we'll consider again the denominator. The denominator, we can use this division sign. This division sign is this. We'll take this 1 minus, we'll say tan theta plus tan theta is going to give us 2 tan theta. 2 tan theta times theta is going to give us 2 tan square theta divided by 1 minus. If we multiply again, tan theta times tan theta is going to give us tan square theta. Yeah, this is it. So for reciprocate now, tan 3 theta, we say 2 tan. Yeah, we can find the LCM instead, because this is over 1. So we're going to be 1 minus tan square theta. This into this is 1. 1 times this is going to be 2 tan theta plus 1 into this is this. This time this is going to be tan theta into 1 minus tan square theta divided by, here again the same thing, we can find the LCM within this part. This time this is going to be 1 minus tan square theta minus 2 tan square theta divided by 1 minus tan theta. Because this one is this, we find the LCM between this, because this is same as over 1. So this is same as over 1. 1 into this is this time this is this minus this into this is 1 time this is this. So if we expand this value, 2 tan theta plus tan theta times 1 is tan theta minus tan theta times is going to give us tan cube theta divided by 1 minus tan square theta divided by, here again we can add 1. Yeah. Yeah. 1 minus 2 tan theta, 1 minus 2 tan theta. Is that okay? Yeah. 1 minus 2 tan theta minus 2 tan theta minus 2 tan theta 1 minus tan square theta minus 2 tan square theta. So going to give us 1 minus 3 tan square theta divided by 1 minus tan square theta. I think this is this. So if we reciprocate, so tan 3 theta is going to give us 2 tan theta plus tan theta is going to give us 3 tan theta minus tan cube theta divided by 1 minus tan square theta times, this will move up 1 minus tan square theta divided by 1 minus 3 tan square theta. So we have this value. So we find out that this value will cancel this value. So the expression will be tan 3 theta is going to be the expression for the top, which is 3 tan theta minus tan cube theta divided by that value.